A reinforced concrete beam is subjected to a factored bending moment mu is equal to 648 foot kips. Mu means it's factored under safety. So Mn will be mu divided by factor. Okay. For concrete, F dash C is equal to 4000 psi. This is in inches. For steel, Fy, the yielding strength is 60,000 psi. 8 bars arranged in 2 rows. That means it's a doubly reinforced beam. Reduction factor phi, safety factor, 0.90. So mu is this, factor is this. So if I want Mn, that is mu by phi, that is 648 by 0.9. Okay. The beam has overall depth of 35 inches, complete depth. It has 2 inches cover to main tension steel, 2 inches cover to the main tension steel, 1.5 inch clear spacing. The spacing between each of them is 1.5. This is not including the diameter of bar. Okay. And then what else? 2 inches center to center between the bar layers. Center to center between these two layers is 2 inches. That means the centroid between both the bars is going to be at 1 inch distance from the center of the lower beam. Okay. And 2.5 inches distance from bottom face to the centroid of the beam. From bottom face to this centroid is going to be 2.5 inches. So if I want this bottom face all the way till the centroid between both of these bars, it's going to be 2.5 plus 1, that is 3.5 inches. Okay. Now they are asking what is the minimum adequate overall beam depth B. That is what they are asking. Now for this width calculation, if you go and type singly reinforced, it will take you to page number 275 in your FE reference manual. Please understand that though they gave this equation as singly reinforced, these apply for both singly as well as doubly reinforced, because they gave for all beams as part of this. Okay, that is the main one. So if you look at this question, they are asking for the width. Width is present in this equation. A is equal to ASFY by 0.85 FC dash B. This is the B that we were being asked. So, but I don't know the value of A. If I know the value of A, I can simply like take it to LHS and calculate and find out. Since I don't know the value of A, first I need to find what is A. A can be found out from this equation. Mn is equal to ASFY times B minus A by 2. AS is area of steel. Area of steel for number 8 bars can be found out from page number 274, where we have a bar chart here. For number 8 bars, it's going to be 0.79. Since it is going to be 8 number 8 bars, I have to multiply this number of this area with 8, the count of bars, to get the AS or area of steel value. So that is how I get my area of steel. And then what else? Fy is given in the question, the yielding strength. And then D. D is the next question. D, according to the definition that is provided in FE reference manual over here, is nothing but distance from the top to centroid. Top to centroid. I know top to bottom, but now I want top to centroid. Centroid here. I already said the bottom till center here is 2.5. Center till centroid between the bars is 1. That means bottom till the centroid is 3.5. So if I subtract this 3.5 from 35, that will be nothing but my D value. Okay. This is the same D, 35 minus 3.5, that we can substitute here in this equation. So if I do all this, I will get my A value. If I get my A value, I can substitute this A as part of this one to calculate my B value. Very, very simple. So upon calculation, the B value for this particular thing came out to be 6.45. This is called the strength method. The width based on strength is 6.4 inches. Okay. Now, but for this FE exam, this is more than sufficient. If you calculate this part, you will most likely be right. But at the same time, understand, width is not just based on strength, it's also based on the cover. Cover is the minimum requirement. If strength needs more width than cover, then whatever is the maximum width between cover and strength, that will apply. So what do I mean by cover width? So this rebar has to be 2 inches from the edge over here, and then there is 1 inch of rebar here. Number 8 means 8 times the diameter of the number 8 bar. What is the diameter of the number 8 bar? Whenever you want to calculate the diameter of any given number, you just have to divide the number by 8. Number 8 means 8 divided by 8, that is 1 inch. If it is number 4, that is 4 divided by 8, that is half an inch. Since it is number 8, you already know this is 1 inch diameter bar. So this 1 inch diameter bar means 2 plus 1 plus 1.5 here plus 1 plus 1.5 here plus 1 plus 1.5 here plus 1 plus again 2. That is 2 plus 2 on both the sides 4. 1, 2, 3. 3 times 1.5, that is 4.5, that is 8.5 plus 1, 1, 1, 1. 8.5 plus 4, that is 12.5, approximately 13 inch. So at least a 12.5 inch minimum width of this beam is required. That is a mandatory requirement. Between the previous strength obtained requirement of 6.40 and 12.5, since 12.5 is more, for this particular problem the right answer would be 12.5 or anything higher than 12.5, but not lower. Okay, both 13 and 15 are right, but economically speaking 13 is more of a ballpark. 12 doesn't qualify because whenever they say 12.5, for safety you have to go higher, not lower. So 13 is the right option for this question. But for your FE exam, most likely they will not look at the cover aspect, they will only look at the strength aspect. So please understand that all you have to do is you got to find the A value from this equation, from Mn equation, and substitute in the ASFI by 0.85 times FC dash B equation in order to find the B value. If you do that, that is called strength, width based on strength. That is more than sufficient. I hope this helps.